Well, today we're going to look at solving radical equations. Now, when you do all the correct work in solving a radical equation, sometimes you get an answer called an extraneous solution, which is a solution that occurs when you correctly solve a problem, but doesn't work in the original problem when you plug it in. So, that's something that will often happen, not always, but often when you're dealing with solving radical equations. Now, when we're talking about radical equations, we're talking equations where you have a variable inside of a square root, or a variable inside of a cube root, or a variable really in any side of the root. So down below is kind of the approach you want to take. You want to get the root on one side all by itself. And then you want to undo that root by raising both sides to a power that cancels out your root. And then normally you just go ahead and solve it like a normal equation then. Now if it does happen to still have a root after you raise it to both sides, well then you just repeat the first couple steps again. So let's take a look here. So we have a square root on the left, we have a square root on the right, so we can't really get well, we have our roots on one side each by themselves, so we're going to just go ahead and undo our square root by squaring both sides. Now on the left side, your square root is undone by your squaring, leaving you only with what was on the inside. Same idea on the right side. Your square root undoes your squaring, leaving you only with what was on the inside. Well, we don't have any roots left, so now we just solve it like a normal problem. So I'm going to add a 2x to both sides. And then I'm going to get rid of that 4 by subtracting a 4 from both sides, and so I get negative 5 is equal to x. That is my answer, but remember, we got to be concerned about those extraneous solutions. So I need to go ahead and double check this into the original problem to see if it actually works. So I need to go ahead and rewrite all this and plug it in to see if I get the same thing on both sides of my equal sign. And so I'm going to plug in my negative 5 for both of these x's. And you'll notice on the right side, we get 4 minus a negative 9, which is 4 plus 9, which is the square root of 9, which is a 3. Then I need to take a look at the left side. I would get the square root of a negative 1. A negative 2 times a negative 1 is a positive 10, which would be the square root of 9, which does end up being 3. Since I plug it into my original, and remember you always have to check your original, and I get the exact same thing on both sides of the equal sign, it works. So this would be my answer. Now sometimes when you solve it and you work it out and plug it back in, you get different numbers on the right side and the left side. Then it does not work. So just be aware of that, and that's referred to as that extraneous solution. So here, we need to get the root by itself. Oh, hunky-dory, it already is. So then we can just undo our square root. To undo a square root, you square both sides. Well, when you square the left side, you end up getting just your normal x. And you square the right side, 3 times 3 is 9. And then you want to go ahead and check it, plugging it into the original. And we want to see if we get that. Well, if we take our 9 and plug it in, and we know the square root of 9 is 3, and 3 does equal 3, so that means our answer of 9 does work. So here, we got to get the root on one side by itself, which it is. We have a square root again, so then we'd have to square both sides. Because what you do to one side, you want to do to the left side, or both sides. Here, we get this, 3 times 3. Here, our square root is undone by our squaring, and it leaves you just with what was on the inside. And then we can go ahead and get p by itself by going ahead and adding 2 to both sides, and we get this. And then once again, you want to go ahead and check it into your original to see if it actually works. So I'm going to go ahead and go 3 and wonder if it gets the same thing as what I do when I plug it in over here. And then I want to go ahead and take this 11 and plug it in for my p, We know that on the right side, 11 minus 2 is 9, and we know the square root of 9 is a 3, which does match with what we had on the left side, so this would be our answer. So we need to get the root by itself. In the prior problems, we already had roots on one side by themselves. So we'd have to undo our plus 2, so I'm going to subtract a 2 from both sides. And now I'm going to undo my root by squaring both sides, because squaring undoes a square root. And I get this. Then to get k by itself, I just divide both sides by 5, and that's my answer. But once again, I need to check it into my original problem to see if it works. Now, a lot of times it will, but not always, so remember to check it. And we're wondering if we get the same thing. So when I plug in my red 5 for my k, I would get the square root of 25, still with that plus 2, and the square root of 25 we know is 5, add 2, and we get 7, which matches this here, so that means 5 works. So here we need to get the root by itself, so we have to undo timesing by 2, so I'm going to divide both sides by 2. And then that leaves me with my root on one side by itself. Well, when your root's on one side by itself, you can undo your root. So to undo a square root, I need to square both sides. So the square root and the squaring on the left side cancel, leave me only with what was on the inside. On the right side, 1 times 1 for 1 squared is just 1. Get a by itself, and I get a negative 3. And then once again, we got to check it into the original to see if it works. So I'm going to plug that in over here. And then I'll go and try to figure it out to see if I get the same thing on both sides. So if I plug in my answer of negative 3 for my a, on the left side I get 2, I get the square root of 1. Well, I know the square root of 1 is 1, so I get 2 on the left side, which matches 1 over half I have over there, so it does work. Same idea here. I got to get the root by itself, so I got to get rid of that minus r in there in front of my root. To undo that minus r, I'm going to add an r to both sides of the equal sign. And then I have to undo my root, so my square roots is going to be undone by squaring. Now, I squared the right side, now I need to square the left side. On the right side, my square root is undone by the squaring I just put there, so it's just what's on the inside. Now, on the left side, if I had on the left side this with multiplication, I can apply that exponent to each one. And I get an r squared times a 4 squared, which is 16. But that's not what we have. On the left side, we have a subtraction sign. So you still really have to think about what does squaring mean. And so squaring means multiplying it by itself. So on the left side, I'd have to write it out twice. And then I'd have 2 terms times 2 terms, so I'd have to FOIL that out. Or double distribute, however you want to think about it. And so when I do that, I end up getting this. And now we end up having a quadratic equation. Remember, to solve a quadratic equation, you want to go ahead and get it equal to 0. So my 4r and 4r on the left would be a negative 8r, but to get this by itself, I'd have to subtract a 5r. So my minus 4r, and minus 5 is a minus 13r. And then to get rid of my 26 on the right-hand side, I'd have to add a 26 to both sides. And so that would then be a plus 42. Then you'd want to go ahead and do your AC factoring, and when you go through all that work, you would eventually get down to an r minus 6 and an r minus 7. And then you have to go ahead and set each parenthesis equal to 0, and so you get r to be a positive 6. Set the second parenthesis equal to 0, and you get r to be 7. And then we have to go ahead and check that into the original. So I'm going to bring this down. And now I have two answers, so I have to check both answers into my original. So I'm going to write this out. I'm wondering if 4 is equal to the opposite of my input plus the square root of 5 times my input minus 26. And I need to check both my answers, so I'm going to do that for both of them. And it's not what I wanted. Why is it? What am I hitting here? I'm clone. There we go. Sorry about all that. So I'm going to take my green 6 and plug it in. So I'll plug 6 here, plug 6 here. I'll take my 7 and plug it in. I'll plug in a 7 here and I'll plug in a 7 here. So this is a negative 7 plus the square root, and then it's a 35 minus 26, which is a negative 7 plus the square root of 9. A negative 7 plus the square root of 9, which is 3, which when I add these together I get negative 4. So that matches this, so the 7 works. I got to also simplify that down with my black and green by plugging in this. And then I get the square root of a 30 minus 26. And then I get the square root of 4. And that also matches. And I get both answers working. So pause the video and go ahead and read through this problem. Now we are taking and wondering how far above the ground. That means we're looking for h. When we are 1 second, which is our time. So this is going to be 1. So I'm going to have well, I got to get the root by itself, so I got to undo that dividing by 4. So I'm going to multiply both sides by 4. On the left side, timesing by 4 cancels out the dividing by 4. Once the root's on one side by itself, it's just like our prior problems. And then subtract a 50 from both sides. And then we get h to be 34. Now, we are looking for our height, and our units for this problem are in feet, so it'd be 34 feet. But once again, we should go ahead and plug it into the original to verify that it actually does work. And we're wondering, do we end up getting 1 out? So if I take my answer 34 and plug it in, I get the square root of 16, which I know is 4, and 4 over 4 is 1. So yes, it does work. So 34 feet is my answer.